Or one time. All right. So this is CS50. My name is David Malan, and welcome to the first in-person CS50 Educator workshop in 3 years. This is a tradition that started back in 2015, and among our goals as CS50's team has been to facilitate for teachers in the US, around the world, to be able to adopt or adapt curricular materials like ours in the spirit of open courseware. And so among the goals for a workshop like this, not to mention all of the materials that are available online, is to really give teachers, both experienced and inexperienced, an opportunity to meet each other, forge a community of educators, particularly if you're like the only computer science or math or not even either of those at your own school, so that you feel you have a community to lean on for materials, for support, for questions, and the like. We're joined today and tomorrow online, both via YouTube as well as via Zoom, from other teachers from around the world. Just wanted to reveal them on the screen. And if you're hearing me on the internet right now, if you'd like to go ahead and turn on your cameras, we have a tradition of a souvenir photo when we do things via Zoom. So in a moment, you'll see a whole bunch of faces, hopefully, waving and smiling. And if you're hearing me on Zoom, even if you've already said where in the world you are, please go ahead and say it again in the chat so that everyone here at Harvard can see who you are as well. And let's give folks a chance to wave here. And let's see. Oh, sorry. Let me fix this. That's it. Oh, interesting. All right. So here we have everyone here from Bangladesh, Colorado, Philippines, Malaysia, Egypt, Germany, Bermuda, Lebanon, and Massachusetts. All right. We'll end with Massachusetts. So so nice for everyone online to be joining us as well. And Rungshin, are we OK with some screenshots at this point? Yes, we are good. So we'll post a souvenir photo later on as well. So those of you joining us via Zoom, please, and YouTube as well, please feel free to ask questions via the chat. I'm going to go ahead and log out of my screen here, but we still have the stream going for everyone else. And wanted to give everyone a sense of what awaits for today, whether you're here in person or online. So the first session today, we'll talk about CS50 Explained, and we'll give you just a sense of the history of the community that has been building over the past several years. I'll then turn things over to CS50's own Carter Zanke, the course's preceptor, who helps run the class here on campus as well as online, to focus on curricular topics and questions in particular. After that, our own Rungshin will walk you through the availability of some of CS50's software tools for both teaching and learning, some of which you might have used, some of which you might have not, some of which may solve problems for you, some of which may not, and we'll give you a sense of really the menu of possibilities that are available to you. For those of us here in person, we'll have a nice lunch. Those of you online are welcome to have breakfast or lunch or dinner, depending on where you're at that point. And then we'll resume with Audra, one of our wonderful teachers from CS50's community, to give us a sense of CS50X, which is our outward-facing initiative for universities, for community colleges, and beyond as well. We'll focus thereafter with Peter, another one of our teachers in our community, focusing on year one, day one success in your teaching your very first class with CS50. And then for those of us here in Cambridge, we'll do that thing where we stroll around campus, taking a look at Harvard, taking a look in person at Sanders Theater, where CS50 itself is taught. And then we'll have a nice dinner at a restaurant called Changsho, which during the school year is where we take students every Friday afternoon for lunch. So I hope those of you online will forgive that we can't quite take you here or here, but we'll post some videos and photos thereafter as well. Before we dive in, any questions or topics from this group here? No? All right. Well, just wanted to do this just to make sure that it's not lecture format alone. Not going to do introductions of everyone all at once, but we did our online folks. And just wanted to ask for like 2 or 3 volunteers to say hello to the group for maybe the side of the room that you didn't just meet. Can I make eye contact with anyone who's willing to take on this? Yes, Peter. Thank you.
Hi, my name is Peter. I've been working at the Colorado Springs School, and and I'll be presenting year one, day one. And something. Yeah.
Sure, something. You're about to tell us something. So.
I'm a big skier. How about that?
Wonderful, wonderful. Now that Peter's broken the ice, can we go over to this side of the room? An introduction as well? Yes. Here. Oh, yeah. Oh, were you?
Yeah.
OK, there we go. Volunteering.
OK, hello. Hello, everyone. My name is Amir. I'm originally from Jordan, but now I work in New York City. I'm a teacher at an IB school, and I want to actually incorporate computer science, AP, CS50 into my classroom so that I can combine the best of both worlds.
Wonderful. And how about one final volunteer just to break the ice, and we'll see if we can integrate a few more of these over the course of today and tomorrow. So oh, there we go. Thank you. Here we go.
Hello, everyone. I'm Ken Loomis. I have actually taught CS50 X Miami in the past, but I'm now teaching CS50 AP in the high school. So it's a transition to me, so I'm just happy to be back and meeting new teachers to talk to.
Wonderful. Well, welcome to you three, to everyone as well. And what I was about to do, for what it's worth, is in the absence of volunteers, at least in CS50 or my own classes, I would tend to cold call on someone, but not to speak uncomfortably and present themselves, but to then nominate someone else to take the microphone on their behalf. So that's what would have just happened were it not for Ken. So thank you to Ken. So why don't we go ahead and dive in here. Please feel free to interject at any point with questions. If you're following along online, please feel free to ask questions of Charlie, one of our own teaching assistants from Yale University, who will be there to intercept and either answer for you or vocalize them to me here in the room. The goal at hand then really is to just give you a sense of the broader community, and also particularly a lot of the pedagogical decisions, for better or for worse, that have gone into CS50. And the goal here is to not just serve a whole bunch of Kool-Aid, certainly, so to speak, but to give you a chance just to hear how we think about things and then decide for yourself what works best for your students, your community, your school, or beyond. So this is CS50 in a typical healthy fall semester. So it's one of Harvard's largest classes, and this here is Sanders Theater, which we'll stroll over to in person later today. And it's a traditional structure, CS50, here on campus, in the sense that we have weekly lectures, in our case once a week at the beginning of the week for a few hours, followed by smaller scale sections or recitations led by our teaching assistants or teaching fellows, who themselves typically tend to be undergraduates. But the story of, I think, what we do and why we do it kind of goes as far back as 1999, when I first started teaching for Harvard's Extension School, our continuing education program here on campus, that very early on became part of Harvard's distance education program. So, we take for granted YouTube and similar technologies nowadays, but back in the day, it was kind of a thing to put any sort of content streaming online. And it wasn't even streaming, really, at the time. You had to just download things old school on whatever device. And so this was an introduction to computers and the internet, this first course. But this is actually how we first filmed this here course. If unfamiliar, this is a VHS tape. This is an older school technology that we used to film with a traditional camera. And my fondest memory, though it wasn't fond at the time, was when one of our teaching fellows, who at the time was a friend of mine, and still is a friend of mine, was filming the class. And we have footage of all of a sudden the camera angle when, vroom, because he fell asleep during said class. So nowadays, we have an amazing team who, to my knowledge, has never fallen asleep during class. And we focus particularly on improving the capture of CS50 and all of its contents to really give students the clearest of possible views into the classroom, so that it really isn't the technology anymore that's getting in the way of their experience. But it did back in the day. This is a blown-up version of this type of resolution we had when here I was teaching, barely tell. I was wearing a tie at the time, too. That was about the last time. Trying to convince everyone in the room that I was sort of qualified and old enough to be there. But one of my takeaways from that very first year was this. This is a very simple PDF from February 9th, 1999. And this is the first piece of curricular material that I myself put online. Because a week prior, on February 2nd, 1999, it hadn't even occurred to me to post my materials online for our own students. It certainly didn't occur to me to think that anyone else in the world would care to sort of lean on us or perhaps adopt or adapt the same material. And these were just our notes for the day. And it was because of a student's suggestion that I realized, OK, I guess we should just post online everything that it is we start doing. And that simple idea really has informed for us the past 20 years. Now, in 2000, we moved from VHS tape to real video, if you recall this technology. And the window was about as big as this. So this was the size of the video on screen. So the resolution wasn't exactly where it is today when it comes to 4K resolution and the like. But at least we were online and we were on the internet. Fast forward a few years to 2004, and the iPod became a thing, and podcasting came into existence. And we thought this would be an interesting technology to kind of steer into as an introduction to computer science, introduction to computers and the internet. And so we made what was my extension school class at the time freely available as MP3 files, essentially, that you could download onto an iPod. The motivation for which was purely for our own students, to make it easier for them to not have to have a constant internet connection to just watch or listen to lectures, but rather they could go to the gym, they could commute on the train or the bus or the like, and just generally take education with them all the more readily. Now in 2005, the video iPod came out, so that was a quick change, and we started making QuickTime movies available of the same, so that students could similarly download the asset and move on. This was my skill with Photoshop, both in 2005 and probably still now. But this is the John Harvard statue, too, that you all here in person will meet later today on our tour as well. But we started looking quantitatively at how this kind of open courseware, even before the word really existed, was being received. And what struck us was that there were a significant number of downloads, certainly beyond the 100 or so students we had on campus. So on the x-axis here is the number of downloads of these various y-axis video files, or in this case, MP3 files as well. And so like several thousand people seemed to take an interest in this material. And so that, too, was kind of informative that there was this whole audience, certainly beyond campus, that may very well benefit from or not have access to the kinds of educational resources that you and I might otherwise take for granted at our institutions. And it was very international as well. Even though at the time it was about 60% US based, we had a large swaths of other countries as well. And these were some of the bigger percentages at the time. Nowadays, the other slices have grown even further, such that CS50's own audience is about 30% US and about 70% international instead. And here, just as a fun technical fact, was how many, let's say, gigabytes of data were being downloaded by people around the world early on via MP3s and QuickTime movies. So this here would be 6 gigabytes. And so this was November of 2006. And at the time, hosting video content was actually really hard. Like, there really wasn't a YouTube as we know it today. And even when there was, it was like a 20-minute limit, which wouldn't be enough for a typical class. And the problem was here that the 6 gigabytes was a lot, certainly back in the day. But there was a company here in the US called DreamHost. And you could sign up for a free web account for DreamHost. And they gave you like 6 gigabytes per free per month. So we had ultimately not just one, not just two, but we had multiple DreamHost accounts that we were uploading identical content to. And as soon as we hit the month's limit, we would just roll over to the next one and sort of redirect the students. So sort of scaling was hard and very manual back in the day. But thankfully, technology has helped with that. But now, all of these materials, and CS50 itself, is available via this license here, which is Creative Commons, which means it's available for anyone in the world to use, so long as it's attributed by them to, say, CS50, used for non-commercial purposes, and it is shared alike in the same way. So that if teachers alter the material in some way, add their own flair to it, that we would ask simply that they make it available online in that same spirit as well. Here, if curious, and I'll post this on our workshop page for today, was our look, too, at how podcasting and now digital technologies more generally really impacted our own students in terms of that same portability. But now let's enter sort of almost present times with CS50 itself, which is our introduction to computer science and programming here officially for undergrads at Harvard College, but also now via these other audiences as well. So it is offered not only to kids on campus, but also typically 100 or more adults around the US, around the world through Harvard's Extension School, which means folks who are not of traditional college age can still pursue a degree or a certificate or just fill in gaps in their knowledge. And in our case, what's different through Harvard Extension School versus just open courseware is that just like the college offering of this class, students through Harvard Extension School have access to a dedicated teaching fellow, or TA. They get formal grades and feedback in a transcript and the like, whereas open courseware is much more community-driven and supported, as you'll soon see. All of the materials have long been available on websites that look a little something like this now in a more modern form, but it was worth noting, too, that besides just the lectures, besides just the videos and the MP3s, we've really focused too on providing problem sets, as we call them, homework assignments, and the sort of material that others might very well want to adopt or adapt particularly for their students. So we introduced in 2007, when I took over this here class called CS50, a very deliberate change in curriculum focus. In 2006, the course was introducing assembly language, if familiar, of all things, to students in the first week. And if unfamiliar, this is like very low-level, cryptic-looking code that is actually appealing to a certain demographic of students, but I dare say not a large demographic of students. And so we instead inverted things, and our friends at MIT had invented a new graphical programming language called Scratch that at the middle school level, teachers might spend, a good semester, maybe even a whole year on. For us at the college level, and I think even the high school level and certainly beyond, we spend about a week on it just to introduce certain concepts like functions and loops and the like, but to give students this very visual mental model that they can latch onto and not get stuck with semicolons, parentheses, and sort of stupid distractions that might otherwise hit them with more traditional languages like C and the like. We very deliberately altered the problem sets to at least have some foundation in popular culture or mental models that students already have. So even though one of our first homework assignments in C is just to use some little hashtag symbols to print the equivalent of a pyramid like this, we very deliberately connect those dots conceptually to a game, whether it's the original Super Mario Brothers or the latest and greatest on the Nintendo Switch, to students so that they get why they might care to do something like this, so it's not just ASCII art, so to speak, on the screen. We introduce them to real-world domains like cryptography and giving them a sense of how they might rotate letters in an alphabet in English or any other and scramble or encrypt and then decrypt information. We give them things a little something like this. And this isn't quite one of those magic eye puzzles, but if you apply in code a red filter to this, the equivalent of taking a red piece of plastic from cereal boxes, at least growing up in the US, this should reveal a secret message. Can anyone see it with their own human eyes without that piece of plastic? This will be a throwback to perhaps a game you might have played growing up. It was Professor Plum in the lounge with the candlestick. So this is an allusion to Clue or Cluedo, which is a popular board game, at least here in the US. But this is meant to capture, too, a problem that at the end of the day is really just about a two-dimensional array of pixels, if you will, up, down, left, right, but giving students a fun way of exploring the same so that the sort of reward at the end is to actually solve some puzzle or problem like this one here. And then, of course, fast forward to the end of our semester, if familiar with CS50 already, we end with web programming. So we start with Scratch, we move on to C, a little bit of Python, JavaScript, SQL, HTML, and CSS. And by the end of just 3+ months, in our case, or 1+ year or so, in the case of CS50X or CS50AP, students are building their very own web application. And that really is core to the design of CS50, to sort of have a significant expectations of students, and it's a significant slope, but it starts low in terms of accessibility, but ends high ideally, so that by the end of the course, students are either well prepared to go take some other class in computer science or programming, or they have enough technical skills and enough conceptual understanding that they can go back to their own preferred interests in the arts, humanities, social sciences, and just like write code to solve problems, even if it's not going to be their full-time job. And ultimately, one of the motivations for these several languages in CS50 itself is that we haven't wanted students to exit the class thinking, oh, I took a class in C, or I learned how to program in Python. We really want them to say only, I learned how to program. And indeed, that's meant to be the case. A certain type of programming, procedural programming, if familiar with that, as opposed to functional programming or object-oriented, but programming, period, nonetheless. Let me just pause here, since this was a lot all at once, and see if there's any questions or confusion. Anything at all? No? And Charlie, do feel free to relay as well. So among the tenets of the class, I dare say, that we sort of figured out over time. These were not things that we decided in 2007, this is how we shall characterize CS50. But I dare say this is perhaps a helpful mental model for what characterizes this course in particular, is one, that accessibility. And that was borne out by our use of Scratch in the very first week, which we still do some 15+ years later. But two, accompanied by a degree of rigor. Like, it was not our goal to make this a very large, popular gut type class on campus, but rather to really keep expectations high. And I do dare say Philosophically, I think in general education, certainly here in the US, does not hold expectations high enough for students. And indeed, I think if you create an environment that's characterized by this very accessible on-ramp, but where they do feel like I am taking a rigorous class, I am taking a Harvard-like class or the like, I do think there's something motivational in that, so long as you can provide the requisite support structure to get all students from that starting line to that finish line. And I think we've focused unusually, case in point here today, online and on campus as well, on community, like making students feel part of some community that's not competitive. The goal is not to outdo some classmate, but rather to get through it together. And as you'll see some visuals over the course of this morning of our events and community outreach type events, the goal is to really make students feel like they are indeed part of this community. But in terms of that support structure, at least at the university level, this is one implementation detail that we have found helpful. And it's easier said than done, I think, with smaller classes. If you're an individual teacher, no TAs, no such support. But just to give you a mental model for how we think about things, within CS50, because we have hundreds of students on campus, we categorize students, or we ask them to categorize themselves into comfort levels on the very first day or week of the class. Are you among those less comfortable, more comfortable, or somewhere in between? And we don't give a very formal definition for this. There's no pre-test or entrance exam where students answer this question for themselves. They just kind of know. Like if you're uneasy with the idea of being in CS50's classroom in that first day, you don't know why you're there, you followed a friend in, like you're probably among those less comfortable. If though you've been programming since you were like 6 years old, but you taught yourself online, you don't have any formal knowledge, well, maybe you're among those more comfortable. And if you're not sure, you're by definition somewhere in between. With that said, most recently did we add, with Carter's help and others, another track within our on-campus class for those least comfortable. And these are for the students who aren't just uneasy with computers or didn't have necessarily opportunities to program before, but rather those whose math skills or STEM skills or really just college preparedness might be lacking just because they didn't go, for instance, to a preparatory school at the K-12 level, or they didn't necessarily come in sort of knowing how to succeed, especially in their first semester as a first-year student in, say, a university environment. And so what this means for us is that among our several hundred students, we have these sections or recitations of maybe size 6 to 20, depending on the comfort level, led by one of our undergraduate teaching assistants so that students feel part of a big class, but also a small class as well. And these different sections will operate at slightly different paces, but more importantly, it's the grouping of like-minded students. The kids who are less comfortable don't feel like they're competing with the kid who's more comfortable, who's rattling off words and jargon they don't even understand. And conversely, those more comfortable don't feel like they're being sort of held back by students whose questions, like they already know the answers there too. So simply separating those demographics at a lower level, but keeping them all together at a larger level, I do think has worked well for us structurally. At the university level too, we have office hours, and these are things we have tinkered with over time in terms of their details. The office hours means walking into a professor's office and just asking questions, or in our case, not only myself, but our teaching assistants as well. And we've experimented with models like these, where we reserve the undergraduate dining halls, one of which we'll go to for breakfast tomorrow morning, and we invite students to bring their laptops and bring their questions, and we bring our teaching assistants or teaching fellows. And it's actually delightful early in the week. It's actually very photogenic, suffice it to say, but it also has accidentally created higher than intended stress levels, for instance. So we've started to move away, for what it's worth, from this model, because I dare say there's this inflection point after which the demand for questions being answered is higher than the supply of our teaching fellows and TAs to do so in a stress-free, in an educationally productive environment. And we're actually finding this even at Yale, which trails Harvard in terms of years of offering. And as Yale's class has gotten larger and larger, we're starting to feel, I think, these same pain points. So we provide this as just kind of an idea, because for us early on, some 10 years ago now, the goal here too was not just to support students curricularly in the class, but to also create a buzz on campus, create an environment where students who aren't taking CS50, but were in the dining hall just working on their own classes, might look over the shoulder of their friend and say, oh, what is this you're learning? What is this you're working on? And to sort of raise the visibility of computer science on campus. And so this, therefore, is representative, whether at the university or K-12 level, of, I think, just ways that more socially, but academically, you can draw attention to what you're doing in your own classes or what you want your own school to achieve ultimately. And we have this tradition of lunches. We'll do it by dinner time tonight, but lunches too, we happen to get together for sort of opportunities socially like this. And in our case too, since someone's got to pay the check, we've collaborated with alumni from the university. We've collaborated with local companies. And this is something we would generally encourage for any of the sort of visuals and the larger scale events you see over the course of this weekend. Whether you're a small school out in the suburbs or a city school or the like, very often finding some company, finding some local advocate is a great way to partner with industry and have them bring swag for your students or invite them to lunch and talk to people from the real world about full-time jobs, part-time jobs, summer jobs, what it is to work in industry. And so we've tried to very deliberately intersect the class, not curricularly so much with industry or academically, but socially, to give students those opportunities to interact with folks from the real world. Some of you I know have participated in our on-campus or off-campus CS50 Puzzle Day. And this is actually one of my favorite memories or favorite traditions each year, is just having a bunch of smart people, really excited students get together and of all things delight in what everyone here is looking at, which would have been the solutions to some very challenging puzzles up there on the wall. And so what we do on campus at the start of the year is invite any students, whether they're taking CS50 or not, to come to a location on campus. We hand them a packet of puzzles, which are like logic puzzles, not jigsaw. And the goal in small teams is to collaborate for a few hours and try to solve as many of them as possible. And then there's some fabulous prizes for the teams that finish the most quickly. But the real intent is just to emphasize at the beginning of our school year that computer science really is about problem solving. And it's not about heads down in front of a computer as students might have perceived it or perceived their friends, say in high school or middle school or the like. It really can be about collaboratively solving problems, even without using or needing a computer. In fact, these puzzles have nothing to do with computer science. It really is just about sort of logic and smarts. And so we do that to get students excited more generally. At the end of the semester, in our case, sometimes at the K-12 level among our CS50 AP teachers, we encourage a CS50 hackathon. In our case, we invite students to a large space on or off campus to bring their laptops again and their final projects, visions and goals for their capstone experience. And we give them, in our case, 12 hours to work on them with some degree of focus. In our case, we start at 7 p.m. at night. We end at 7 a.m. in the morning. So it's very much a sort of collegiate type design. For K-12, we recommend perhaps daytime hours, which we've done, starting at 10 a.m., for instance, ending at 2 p.m. or the like. But this is meant to be not only an environment where our teaching fellows and our students are all together just asking questions of each other and moving forward on these projects, but also maybe taking naps around 3 or 4 a.m. And in our case, too, because we're fortunate to live near an IHOP, an International House of Pancakes, we also bring anyone who's still awake at like 5 a.m. to the local pancake place for some breakfast as well. But the goal there is really to create not only this supportive academic environment, but one of those few collegiate or scholastic memories that you have that isn't necessarily purely social. It is indeed academic. And it's similar in spirit too to what we try to achieve at the end of the term, which is the CS50 Fair, which is after students have submitted those final projects. We invite students and faculty and staff from across campus to gather in a large space. Students again bring their laptops or phones on which they have their very own software that they themselves have hopefully submitted just in time. And we invite them to look on their screens of their classmates and friends at what it is they have created. This is one of my favorite memories from 15 now years ago, but this is not an uncommon sort of experience for students who aren't in CS50 to really take an interest in, a delight in what it is their friends have made. And most important too, I think, is to emphasize that at least for our college students here, 2/3 of them have never taken a computer science class before. So a super majority of the students and of these faces here on the screen had literally never programmed 3 months prior to building CS50 Finance, their web application, building their final project and demoing things like this. Let me pause here to see if there's any questions I can answer. No? OK. Charlie, did you want to vocalize something? No?
Yes, we do have a question from the chat here.
Sure.
Charlene, I'm reading the licensing for the course. What is meant by non-commercial? I'm a solo instructor running small workshops. I don't teach for free. Am I able to use the material?
Typically, yes. So for those who couldn't hear that question on camera, what exactly does non-commercial mean? They're an individual teacher. They might use the materials for their workshops. Generally, that would be perfectly fine. What we mean by non-commercial would be sort of doing something that's not so much individualistic in that way. It isn't just so much professional development, but something more grand in scale. And if whenever in doubt, you can email us at outreach@cs50.harvard.edu. to help clarify as well. And on CS50's homepage, we have some clarifying bullets too. And lastly, and those of you here in person last night, and you online can't necessarily see the t-shirts in the crowd, but we also try to give out t-shirts at the end of our particular school year saying quite simply and quite proudly for students that I took CS50. The goal being really to message that like that was the goal, that was their accomplishment, and even if they take no other CS courses thereafter, they at least have this foundation underneath their belt. And as you can probably see, we also have some I taught or I teach CS50 shirts as well. Just wanted to share with you now, before we pivot to things more pedagogical, to a look at some of those same events and those community aspects, which to be fair, we do at a fairly large scale with 300, 400, 600 students on campus, but a lot of the teachers in our community have done with 10 students, 20 students, or the like. And indeed, we started at a much smaller scale. And I think characteristic of all of these events that we've seen, Puzzle Day, the Hackathon, and the CS50 Fair, is not about connecting with and appealing to just one's own students, but other students in the school, other students in other classes, and really just creating that same buzz. So if we have some audio in the room here, I'm going to go ahead and hit play on this video that our team kindly put together from just before COVID times, which is thankfully traditions we have since now resumed. Those here in person, perhaps there's some Easter eggs when we do our tour later. You'll see a few of those same spots. See if you can notice them along the way. So let's catch up to present time and take a look not only at the curricular materials, but the pedagogical decisions behind them, as well as some of our technological solutions that the team has rolled out over time to support teachers and students alike. And I offer this historical perspective in these more recent years to really give you a sense of all of the various things we have tried and either succeeded at, we think, or failed at in the interest of sharing information that hopefully helps others not reinvent wheels. So in 2010, when among our goals was to provide students with a standardized programming environment, we rolled out something called the CS50 appliance. This is a virtual machine, which is an implementation of a computer in software. So like on Mac OS, you could run Windows 95 or Windows XP or nowadays Windows 10 or 11 in a window on your own Mac, virtualizing therefore the operating system. We did this though with Linux. We wanted to give students a programming environment similar to the historical cluster of servers that we had here on campus, but let them use it on their own Macs and PCs. So it looked a little something like this, sort of like a traditional computer or like a Windows-like start menu here, but it had all of the course's software pre-installed into it. And students could now run it on their own computers. And it was indeed this appliance, so to speak, that actually enabled CS50 to become available on edX years ago, because we couldn't really comfortably give tens of thousands, hundreds of thousands of students access to Harvard email addresses and accounts on the campus. So this was much more portable. That said, it was not without its headaches and technical difficulties. Simply closing one's laptop lid at the time could have, with some non-zero probability, could break things, and this was just because of stupid bugs in software and the like. But there was a non-trivial technical support challenge when it came to having students run anything on their own Macs and PCs. So in 2012, for instance, oh, that was not the segue I wanted to say. Already mentioned that. Let's see. I got out of order here. So so a few years later, we transitioned to a different technology. That'll be my cover here. But along the way, in 2012, I made this point earlier by accident, is when the course became freely available via edX specifically. So in 2007 onward, everything had been freely available, but edX is this massive open online platform via which folks can take courses for free. And so CS50 was among the first classes at Harvard College to become part of that same experience. And we focused particularly not on just using one platform. Indeed, CS50 has tried to go where users actually are, as opposed to creating our own walled garden. So as some of you might be familiar, at this URL is quite the list of various social media platforms, Q&A platforms, and the like, where we've tried to bring the class to students so as to not expect them to have to seek us out in order to get support. And just some of the communities represented actually here today in some form and also in years past were these. So I thought I'd give you a glimpse of some of the faces, teachers and students alike around the world. These are some of our friends from Miami-Dade College some years ago, proudly holding their certificates from Miami-Dade College's Idea Center there. These are some of our students in London when we held a CS50X hackathon for students not on campus but off campus there. Here are some of our students in India working on CS50X Puzzle Day, having downloaded and printed out those PDFs of puzzles that I mentioned earlier. Here is one of our online students in Burma leading as a student himself a whole bunch of his classmates in an exercise about computational thinking. Here are some of our students in Pakistan at the end of that same event, CS50X Puzzle Day. Here are some of our students in Egypt with their own swag, and you can see here sort of CS50X Egypt holding a little Instagram-like poster as well after Puzzle Day as well. Some of our students in Congo working on the exact same puzzles, packets of puzzles therein, and some of our students in Ukraine with whom we were working closely, unfortunately, before the war, but we hope to reconnect too with them before long. And there are so many other communities as well. And in fact, if you participate in CS50X Puzzle Day, you'll see a lot of the photos that get shared online as well. And here's where I wanted to segue before. In 2015, we moved away from that downloadable piece of software to support students' programming environments to something called CS50 IDE, which looked a little something like this. Some of you might have yourself used it. It was based on Amazon Cloud9, which was a web-based integrated development environment. And the motivation here, if unfamiliar, is just that with some languages, like it's pretty easy to get things working on your own Mac or PC. Like Python is pretty easy, but not always. Like there's stupid technical difficulties like the Python program is not in student's path environment variable on Windows. And so you have to jump through these hoops just to get the darn thing to work. And this is such a distraction from diving into the actual intellectually interesting parts of the class, which would be writing actual code. And so the motivation not only for the appliance, but this web environment has always been to get you and me out of the business of technical support, ideally, so that really on day zero, you can dive right into the content you care about, that you want your students to care about. So this allowed students with just a browser, even a Chromebook, so long as they have an internet connection, to access that same software pre-installed in their environment. And in particular with CS50, if less familiar, we really have emphasized industry standard or industry common tools. I have not personally been a fan of a lot of programming environments that oversimplify things and reduce programming and compiling and interpreting code to just like a play button and not really understanding what it is that's going underneath the hood. So we have tried to strike a balance between sort of a graphical interface for your files and a nice tabbed interface for your code, but still a terminal window wherein students will get the nitty-gritty, the lower level details that certainly in industry a lot of them will enjoy actually using once more comfortable therein. CS50 AP is the younger version of that same offering CS50X. So if you're teaching at the K-12 level, for instance, this is simply how we frame this, even if you're not using it for AP credit. That said, CS50 is among the College Board's endorsed curricula for AP Computer Science Principles credit. So if you are teaching at the high school level and want to offer AP credit, particularly in the US, CS50 can be one of the courses available therein. This is one of our diagrams pre-COVID a few years back of some of the community communities with whom we've been working over time. Represented in red here are high schools around the world. Represented in blue are some of the university levels. And so I dare say after this weekend, we'll hopefully have a few more dots to add to the screen, both here on campus and off. And here is our very first CS50 Educator Workshop photo from 2015 that will hopefully replace this year, now that we're back on campus, with a photo of you all, if so inclined, when we tour over to Sanders Theater later on today. This is a photo, meanwhile, of one of our first hackathons for CS50X students off campus. So here we were with a group of high school students from a handful of public schools, from a handful of private schools, at the ungodly hackathon hour of 10 a.m. instead of evening times. But we woke up early and did it during normal times and brought together a whole bunch of students in Manhattan, New York, to work on, in this case, either final projects or even just their homework. And that's another seed I would plant. The hackathon idea doesn't need to be framed around just students' final projects or capstone experience, but really anything. Just sort of creating an environment, maybe some candy, maybe even some pizza, maybe some music or the like, to bring students together to not view homework and coding as necessarily labor, but something to actually delight in, to collaborate in. And what we'll also do during these events like hackathons is punctuate them off camera by offering an optional workshop, like a 30-minute workshop on like how to write code for your iPhone or your Android device, or how to use this library or this SDK. Things that are a little more niche that you or maybe one of your students is comfortable introducing, so that there's more going on than just having one's project at hand. Now, when it comes to materials available to you as teachers, depending on your students, depending on your own interests, there's more than just CS50, the Introduction to Computer Science. We have different versions thereof. And so, for instance, there's a course here on campus called CS50 for MBAs, Master of Business Administration for business students, that's also freely available as open courseware via edX and our own website. The course that I alluded to earlier in terms of Yale University is one of our more intimate collaborations, if only because they're roughly down the road and not too far away here in the US. But CS50 is offered at Yale in particular in such a way that most of the lectures take place here on campus, and we stream them live, we record them online, so the students at Yale mostly watch all of the lectures, by me at least, on video. But at Yale, we have our own faculty, we have our own teaching assistants, we have our own sections or recitations, our own office hours, our own puzzle day, our own CS50 fair. So that's actually a very representative model of how, at the university level, some folks have been using the materials. They sort of lean on us for wheels they might not want to reinvent, be it the lectures, the homework assignments, the software, and focus their most precious resource, themselves, their human capacity, on their actual local students. And for some time, we collaborated in the other direction, too, where we had Harvard students taking what was a Yale course as well. Here, for instance, is the very first lecture that we do still in person at Yale, after which we move everything online. But this is a lesson learned for us over the years that I would encourage you to consider even at the K-12 level as well. So certainly at the university level, it's not uncommon to have TAs, teaching assistants, at least for larger classes. But it's also worth noting that in our case, both at Harvard and Yale, our TAs tend to be undergraduates themselves. And this can be contentious in certain schools, or can be allowed or disallowed. But for us, it's been a very characteristic aspect of the class for some 30 years here at Harvard, as well as in a few other departments. And I would encourage you, even at the K-12 level, if whether it's institutionalized as a structure or just something you could do on your own, sort of deputizing one or more of your strongest, most enthusiastic students as your TA, whether it's official or unofficial, has actually been a very enabling way, we think, to support students better, because they identify with a classmate more than they might you as the older teacher in the room. And they also, for the student serving as that TA, I dare say learn all the more. As we tell our own teaching assistants here at Harvard and Yale, the kind of a secret weapon in life is to, at least in my experience, I learn a lot more when I teach a subject than when, ironically, I take a subject. So we're sort of been doing things backwards, it seems, for some time. But this is to say it's as much an educational opportunity for the TAs or your own students as it might be for you yourselves. And at Yale, for instance, they've expanded this model to other departments and classes as well. Let me pause here, because we're almost out of years, and see if there are any questions. No, very easy or tough crowd. Yeah, Amir.
Is there any plan that you might might continue to do something like you did in New York City for the high schoolers?
Hoping to. In terms of the hackathon, are we hoping to do something similar to that hackathon in New York? Indeed. Now that we've been emerging from COVID, the hope is to ramp a lot of that back up because we were sort of on this momentum and then we took a break, and now indeed that would be the hope. And so we would be happy to be invited to places too, if I may just put that out there as well. So here too, the goal is not to emphasize like what we used to do, but rather why we do what we now do. And so if we fast forward a couple of more years to 2017, we started making other materials available as well, particularly because after 10 years of open courseware, we realized, and this was sort of a mixed blessing, among teachers online who were adopting or adapting our open courseware materials for themselves, once they realized that they had taught some class to their students, well, they still had not just freshman year, but sophomore, junior, senior year. So a frequently asked question became, OK, now what do I teach? And so what we tried to do, at least in our capacity here, is build out more of a curriculum, not just a course, but a curriculum, either courses students could take before CS50 or perhaps after. So online, freely available, is another class nicknamed CS50T, which is actually that same class from 1999, just retitled, that introduces students to technology more generally and things they'll encounter in the real world, but not necessarily assuming that they're anyone other than a typical citizen or consumer, not necessarily a professional specializing in something. But conversely, there's another course called CS50B, which is inspired by that class at Harvard Business School that particularly focuses on the intersection of computer science with business. Issues like cloud computing, intellectual property, cybersecurity. So equipping students with a vocabulary and enough conceptual understanding of how technology works so that if and when they are in the real world in a position to make business decisions, they're hopefully making better decisions because they understand the underlying technology. A year later, we rolled out courses like CS50's Introduction to Game Development, which is freely available as well and introduces students particularly to two-dimensional game development. And it's meant to be taken right after CS50 itself. So here is one answer to the FAQ. What can I do with my students after CS50? Another option is CS50W, web programming, which literally picks up where CS50 leaves off. So we assume they know something about web programming, but now they'll go much more into depth in it, preparing them all the more, maybe for a summer job, for projects of their own, for real world work, or the like. Since then, too, we've rolled out a version of CS50 for lawyers, which emphasizes more cybersecurity, intellectual property, and the like, more of the topics that they might encounter in that space, freely available as CS50L. Just a couple of years ago, with Brian Yu, one of CS50's longtime team members, we rolled out an introduction to AI with Python, a couple years before everyone was talking about AI with any number of languages. But this provides students with a very accessible introduction to the principles and ideas underlying artificial intelligence and gives them practical skills to apply principles from artificial intelligence in actual code. We're actually in the process of updating CS50 AI this summer to include all the more of a look at large language models, LLMs, generative AI. So a slightly updated version of this will be available this fall as well. And now, almost present day, we rolled out a course that introduces students to programming via Scratch. So this is meant to be a course or materials for a course that a teacher could use really at any level, whether it's middle school, high school, or college. But it spends more than just like an hour on Scratch, as we do in CS50 itself, and breaks it down more into modules on functions and on loops and conditionals or the like. So it gives you more curricular resources, especially if you want to spend more than just a day, more than a week, but maybe a month or more on that particular subject, preparing students perhaps all the more for CS50 itself. We transitioned 2 years ago, too, to what we call Visual Studio for CS50, which is essentially our own adaptation of VS Code, a very popular open source product, hosted, in our case, on top of GitHub, which offers a new service called GitHub Codespaces. So very similar in spirit to CS50 IDE from Amazon, but this is, dare say, more of an industry standard now. And more excitingly, it has a whole ecosystem of extensions that you can develop, that you can download and install for free. It has more language support. We just rolled out with Rangshin's help support for like 15 other human languages just for accessibility in terms of understanding prompts. And so this is the tool if you now use code cs50.io or cs50.dev, this is now what you're using. And pedagogically here, among our goals has been, by the end of a class, we want students ideally to stop using CS50's infrastructure. We want to take off the last of those training wheels. And what's wonderful about VS Code is that in their browser, using our version online, it looks like it will on their own Mac and PC. And so what we try to do now at the end of CS50 on campus is get students off of the web version, not because they are not allowed to keep using it, but we want them now, 3 months later, to download Python, download VS Code, go through the stupid headaches and steps of like figuring out how to get it to work. But once they have 3 months of some computer science background, they have more confidence, and they can sort of deal with the real world realities of software that can be difficult to configure, but they know how to program at least at that point already. So it postpones, dare say for now, the inevitable, but it doesn't create a barrier to their excitement, to their comfort at the very start of the term. And now most recently, do we have a final, another introduction to programming, this one with Python. And this is meant to be a course that you're welcome to adopt or adapt in any form to perhaps use after CS50 itself, maybe even during if you kind of want to expand our segments on Python within the class, or even before. So a frequently asked question among incoming first-year students at Harvard is, how should I prepare for CS50 over the summer, for instance? And the official answer is always, well, you don't need to, because 2/3 of your classmates also will never have programmed before. But the reality is it's still an FAQ. And so our answers nowadays are optionally to undergrads. Well, if you really want to prepare, take this class online for free at your own pace or on edX, or take the Scratch class even, if only because then you can come in with a little more comfort. You can make the first week or two seem a little more familiar so you're not all the more intimidated. And so this is a helpful way, perhaps, to mitigate any of those concerns. And then lastly, where are we at? Thanks to Carter, whom you'll meet again soon, we'll have a new introduction to databases, specifically with SQL, that really fleshes out in more detail what we introduce or tease in CS50. Literally earlier this week with the team, we finished filming a new introduction to cybersecurity. This will be available by October online as well. And we'll similarly focus on issues of securing accounts that you might have, data that you might own, software that you might be using, systems that you might be controlling, and talking about matters of privacy in more depth as well. So that too is and or will be available to all of you under the same open courseware offering, so that you're welcome to adopt, adapt, just watch and learn from, and then take the ball yourselves and run with it in any form. And all of those same courses are available at this URL here. Let me pause here and see if there are any questions before we focus lastly on some theatrics. Anything at all? Charlie from the group?
How is CS50 for programming students with disability inclusive towards those students, and how is access to the course, material support, and assessments friendly for the students?
Sure. Question about accessibility in terms of the course's content and materials. So this was another upside of and motivation for switching to VS Code. That tool in particular is very well accessible, at least for certain disabilities. For instance, it supports very readily for many languages screen readers if students struggle with sight. There are certain tools nowadays, even from GitHub. There is a voice recognition feature whereby students with motor disabilities can, with some accuracy, program using their voice. And this is a technology, thanks to AI, that will only be getting better. There are different themes which can help with sight as well, whether it's for high contrast or lower contrast or the like. And when it comes to CS50's own materials, we caption, using humans still, all of the course's video content. So they're accompanied by SRT files or closed captions thereof. All of our materials are available in HTML format or in PDF format, both of which lend themselves to screen readers as well. The only thing that is not accessible to our knowledge is Scratch, unfortunately. That one's sort of out of our control, but it's very much, I know, at forefront of mind for the MIT folks working on that. And so I would call out that one footnote therein. Other questions from folks here? No? All right. So here, by the way, is a longer URL. Well, here you can Google this too, but here is the longer URL of the same OpenCourseWare license. And I should mention too, in case folks are taking photos, which you're welcome to do, all of these slides are linked on the workshop page already, so you're welcome to download or link to them there. So just wanted to tease one of our biggest initiatives that you'll hear more about this weekend as well. But we, CS50, are very much steering into AI in what I think is a very positive opportunity. It was disappointing to me, at least personally, over the past 6 to 9 months months, at least in the US, where so much of the narrative in education was like negative or fearful when it comes to AI, particularly around academic dishonesty and plagiarism. And that's absolutely an issue that I do think will be exacerbated by tools like ChatGPT and the like. But at least here on campus, as some of you might know, like we have actually focused quite a bit on issues of academic honesty over the years. We ourselves are fortunate, mixed blessing, to have some resources via which we can look for, detect, and submit disciplinary cases to the university to handle when we notice that students seem to have plagiarized some of their work. So for us, this is a long-standing problem. And in any given year here at Harvard, we might discipline as many as 10% of the 600 students. So that is a significant number. Unfortunately, it's in line with peer institutions and introductory courses elsewhere. So this is sort of nothing new, I dare say, for us and perhaps for many of you in the room. I would propose that we, educationally, really focus on what opportunities this now offers. And so we have been thinking about AI really as allowing us before long to achieve an approximation of a 1-to-1 teacher-student ratio, to really amplify like little old me or little old you in your classroom to support your 20, your 30, your 60, your 100 students much more effectively. And so what we've been doing toward that end is experimenting with a few new tools. So CS50.ai is an actual website that you can log into for free with any GitHub account if you have one already. And it gives you a ChatGPT-like interface. But what we've been experimenting with over the past few weeks with Rongshin, with our undergraduate team, is on trying to put downward pressure on just how helpful this tool or these tools are. I dare say right now, if you've tried ChatGPT, you ask it a question like, write me a program that does X, it will write you a program that does X in any number of languages. If you paste in a bunch of code and say, what does it do? It'll do a pretty good job at telling you what does the code do. And most of those types of questions are probably not how you want tools answering your students' questions. It would be like the overly helpful friend in a class just giving the answer instead of leading students to the answer. So through prompting, and more on this later, we've been trying to coerce tools like this to answer in a manner that you as a teacher would be proud of or find acceptable. So for instance, instead of just telling the answer, we're trying to get the AI to ask more rhetorical questions. Like, have you thought about doing X? Or have you thought about doing Y? Or maybe identifying the actual problem, but not telling them how to fix it. Telling the AI, don't give more than 2 or 3 lines of code. Don't give them the whole thing. So this doesn't stop, practically speaking, students from still using ChatGPT, Bing, Google, or the like. So we, for the moment, simply ban the usage thereof by policy. Like that's simply in the syllabus. It is considered dishonest, unethical to use those tools in their current form right now. But we, and with you if you would like to partake, we're trying to at least counterbalance that with, but you may use these tools because we recognize the value, we recognize the positive opportunity, and they're not going to be perfect. They're not perfect right now, but I do think they're going to get better and better and better. And I think this is actually very exciting in terms of being able to amplify your voice and your instruction to all the more students especially. So more on that later today and tomorrow. And lastly, thought I would emphasize now some of the curricular decisions within the class and things that you can do either on a stage like Sanders Theater or in a classroom like this or even smaller therein, trying to create which we think of as memorable moments. And this is sort of characteristic of CS50 in my mind, that beyond just introducing material and introducing programming, we're really trying to give students things to latch onto mentally, both for curricular reasons and motivational. So all of the events, all of the photos, those are really on the motivational side. But when it comes to doing things like tearing a phone book in half, as some of you might have seen me do on occasion, like that's all about theatricality, so to speak. And in my view, this is the kind of thing that anecdotally, like we still have students 15 years later talking about when I run into them at reunions or the like, that time you tore a phone book in class. And the goal is not so much to the goal is not so much to elucidate a topic that doesn't come quite readily to some students, but to give them a connection to the real world. So like, oh, so this stuff is not so esoteric. It actually pertains to things I might understand. And it also helps them have sort of real world metaphors that do help them understand later more advanced topics, for instance. Now, the catch is phone books are getting smaller and smaller and harder to find. So I'm not sure how many more years we can squeeze out this demonstration. And I thought it's only fair, though, if perhaps we do this once. Could we get a volunteer maybe to do this instead of me? I've torn my... Charlie, can we put a face to the person online? All right, so those of you chatting with Charlie in the chat, here's who you've been talking to. Charlie, do you want to introduce yourself again for the group? Let me hand you the microphone. All right.
Hello, everyone. My name is Charlie. I'm a head TA for CS50 at Yale, and I'm currently an intern on our development team this summer.
Okay, wonderful. So, Charlie, here we have a phone book, which I think in our day, used to be about finding names and numbers, which are alphabetically sorted from A to Z in English. And suppose that I want to find, I think it's Eli Yale. So first name starts with E. We'll do E because it's more interesting than Y. Could you go and tell us different ways in which you might find Eli Yale and maybe ramp up to something more theatrical?
Yeah, sure thing. So the first thing I can think of is that with this phone book here, I know that it's sorted alphabetically, right? So I could just start at the very beginning and slowly go all the way up to the E's, right? So I could go page by page here. But this will probably take quite a while, right? Because there's surely a lot of people with names starting with A, B, C, D, all the way up to E, right? Then I can think of another way where I could possibly skip every other page, right? So theoretically, that should double the time, or reduce the amount of time by half that it'll take for me to search through this. But there is a small issue with that, right? And what might be that issue if I go every other page? Yeah. Yeah, exactly. There's a chance that Eli Yale's on one of those pages that I skipped, right? So what's another way that we could take advantage of this phone book, which we know is sorted alphabetically? Well, I know that if I start in the middle here, and I open up to, let's say, the page with I, for example, right here in the middle, I know that I'm looking for Eli Yale, so it starts with an E, right? So where should I go in terms of this phone book to look for the E section? Well, I know I should go to the left. So I can automatically get rid of half of this phone book and then look only in this half now because I know everything I'm looking for must be in this section in terms of Eli Yale.
And I think the next time you tear it, I think people enjoy when you do it much more theatrically.
Yeah. I don't have as much experience as you, but we'll get there.
How about we'll
eventually.
do one more divide and conquer?
Sure thing. So now that we have just between A and I know I'm looking for E, so I'm once again going to go to the middle here. And it looks like right here in the middle, I'm at C here. So I'm going to go ahead and rip this apart again, toss apart this section, and I'm left here. I tossed the wrong section, but in theory, I should be holding this section with C and E. And then from there, we can continue this until we eventually find the right page.
Wonderful. A round of applause if we could for Charlie. Thank you. Yes, question, please.
Less question, more comment. I know it's hard to find phone books, so what I've done when doing this demo is I go to the science department and get one of their chemical ordering catalogs from past years.
Oh.
They've got like 50 of them every year. So.
Oh, that's a good one. For those who couldn't hear off camera or on camera, going to the chemistry department and using one of their ordering books. So some big catalog with paper pages as well. So the goal is, and maybe this will be among, actually, thank you, Charlie, for making it even more memorable this year with the demonstration. But that's actually the kind of joke I would interject with there. And there's our first bug in the class and the like, and to sort of embrace things like this. So I thought I'd just give you some visuals that you might very well have seen in different forms. And I think what's important for me to emphasize is even though we happen to do it in what is admittedly a very beautiful, unusual theater, and we tend to have larger objects, like almost every demonstration we do in CS50 nowadays, I did, for instance, with a much smaller class, a section of 10 or 20 students or the like, using things that I just might find around the home. So here, for instance, is a photograph of the binary bulb, so to speak, that we now use. So this has taken so many different forms over the years. This is when we were in an actual theater that we had stage lights in, so we actually used the theatrical lights literally to turn them on and off in some pattern to represent binary numbers. And we also had enough of them, 64 in recent years, that we have 8 character Easter eggs in the class. So we spell out something with 8 or fewer characters, and it's just kind of for fun for students to kind of figure out what that message is for the day. This was my dream come true and a silver lining of COVID. I have always wanted or fancied the idea of introducing searching, for instance, by using actual doors. Because at least in a computer's memory, especially when you're introducing C, you can only look at one location at a time, maybe left to right, right to left. And that's sort of analogous to having to open the door to see what value is there, and then moving on to the next door, next door. And this is better in some sense than just having all of the numbers for the students to see, because they have this like bird's eye view of everything. But that's not what computers have. So somehow closing doors was an opportunity for us to then search for them. And we fortunately were able to work with a local theater company that first year of COVID because they had no shows to put on and wonderfully had some bandwidth. So they brought them to life in sort of puppet form for us as well. But the more modest and more common implementation for this, for me, is literally to use like a board like this, bring 7 or more sheets of paper from a printer tray, tape them 1, 2, 3, 4, 5, 6, 7 on the board, use a marker and write the exact same numbers under those sheets of paper, and use the doors in the sense of the paper comes up to reveal what's there, and then I can divide and conquer or search left or right. So using more modest implementations is actually the common case. This here was a bit unusual. And there's just a range of some of the values that the team kindly created for us that year. So this here is Brian, who I mentioned earlier, teaching our AI and web class. And here, in isolation during COVID, in separate room, was him introducing, for instance, some of our sorting algorithms, including merge sort, for instance. So these are actually numbers that we just got here on Amazon. And we've done these even lower budget form. Like I actually find that like paper cups or styrofoam cups tends to work well if you just write in a black marker the number you care about, because then you can kind of play this shell game doing the exact same thing of moving these things around. But we also found it useful to just find some shelf like this one here that we found in storage, so that for something like merge sort, which if unfamiliar is a sorting algorithm that benefits by having extra space. So not just the top shelf, but maybe like the middle shelf here too, or if you prefer, even multiple shelves. But the point is more space benefits merge sort. So here is Brian doing some sorting and then finally some merging from top to bottom. And so this is something one can do pretty readily, either in front of the class or on a shelf, that just gives students more of a mental model for what's going on when sorting things. Another that we do nowadays, I just went to Home Depot, which is a big store nearby for hardware, and we bought a couple of mailboxes that you might have at home. Here, for instance, is a mailbox we labeled P for pointer. This is me opening the mailbox and taking out an address, a pointer, so to speak. Well, where is that address? Well, that address is where Brian lives at his mailbox here at address OX123. And Brian here is opening his mailbox, or if you will, dereferencing that pointer. And voila, he finds an actual value therein, which in this case is the number 50. So it's sort of simple theatrics. They can use a box instead of a mailbox. But it's an opportunity too, if you don't have a Brian, to have one of your students or two of your students sort of acting this out and bringing the material to life a little more visually. This here is me and Brian again in isolation during COVID times, but he had 2 glasses of water. We had colored them differently using food coloring, and I intentionally asked him to swap the values of those 2 liquids. So to somehow get the purple into the orange and the orange into the purple. And presumably, like physically, this shouldn't really be possible. And so, OK, now I have to give him a temporary variable so as to do a swap from x to y and y to x. If we can actually use this third temporary variable, then Brian can probably achieve the same. And this is actually a fun demonstration. And typically in non-COVID times, we invite students up on stage in front of the class to do all of these demos. We don't prep them in advance. And I would say 60, 70% of the time, it goes according to plan. Maybe 30% of the time, thank you, Charlie, it doesn't go according to plan. But that too just makes these moments like all the memorable. And we try to use it to course correct, like, why did that go wrong? So case in point, when it wasn't Brian, but one of our students, I realized imprecision in my own wording, and I said, swap the 2 liquids. And so the student simply did this on the stage. And OK, so technically she swapped it. And technically, there are ways using bitwise operators where in languages you can actually just do this without a temporary variable. And in Python, you can do the same with a line of code. But then I realized, too, I have to sometimes strike this balance between embracing the unexpected on stage, which might get us a little off the pedagogical narrative, versus recognizing that that too can be memorable. So we turn the knob different years with how specific or precise we are. And I've been known to sometimes whisper in a student's ear if I really want to kind of put my thumb on the scale and get the pedagogical outcome that I want and not leave everything completely to chance. Here's an example of me also from Home Depot using some buckets. So in the world of hashing, if familiar, the vernacular tends to be to hash things into buckets. So we got literal buckets. We put these suits from a deck of cards on them. And this is me using playing cards, which if you go on Amazon and search for jumbo playing cards, this is what you can find. And so we use these kinds of physical props too, just to bring things all the more to life. So this is me hashing things according to the suit on the card. Here was me sort of tongue-in-cheek explaining why I always seem to wear black. Well, it's because I keep my clothes in a stack. And so if I've got a lot of black sweaters, which are a little faded here on the screen, but there's like 6 or so black sweaters, even if I own blue or red, I never seem to make my way down to the bottom of the stack if I keep, of course, doing the wash and replacing them there on top. And this, too, is not something that's easy to find, but this was an old-timey refrigerator, because in the world of operating systems, there's long been this metaphor of locking a database is kind of like locking a refrigerator. And if you haven't heard me say this tale before, I myself got this from a professor when I learned operating systems years ago, whereby you contrive a story whereby suppose you and a roommate have a college dorm fridge, and you both, one of you comes home one day, opens the fridge, and realizes, oh, you're out of milk. And so you close the refrigerator door, you go out of your room, and you walk across the street to go buy some more milk. Meanwhile, in the story, another student comes home, your roommate comes home, opens the refrigerator, realizes, oh, we're out of milk, closes the fridge, walks across the street to maybe some other store nearby to buy some milk. Fast forward a few minutes later, now both of you have come home with a gallon of milk, but you don't like milk that much, and so now you've got too much milk, and now it's going to go bad, and so this is a really big problem of sorts. And we tend to use milk as like a euphemism for what college students might be going out to buy for their fridge, but in this case here, the point is that you ended up with too much milk, but why? Well, it's because both of you made a decision about information while that information was in the process of changing or being updated, going from 0 milk to 1 milk, and that's why we ended up with 2 milks. So how can you solve this? Well, you can slap like a Post-it note on the fridge, leave a note, and just say, gone for milk, so that hopefully the second roommate doesn't do it. Or more dramatically, you can lock the fridge, for instance, as we did here with the chain and padlock, to make clear that your roommate should not even be able to inspect the value of that variable until it has finished updating. So this is the kind of stuff, too, that whether it's a fridge or just a box, you can maybe even prep 1 or 2 of your students to kind of enact this on stage or in the front of the classroom, just to, again, bring fairly esoteric concepts like database locks and transactions to life here. And so lastly, on this point, have Brian and I, toward the end of the semester, played a game of like telephone tag to discuss callback functions. If you're familiar with asynchronicity and callback functions in language like JavaScript, this might be acted out in such a way where I call Brian and ask him a question like, you know, what's the weather going to be for today? He's not sure, so we hang up. He goes away and looks out the window, and then a few seconds later calls me back. And we literally do this with our own cell phones, or our old-timey phones in this case. And then some seconds later, my phone rings. I get interrupted. I have to handle this event and pick up the phone, and he tells me the day's weather, or whatever the question might have been. So the idea being these asynchronous callbacks that might interrupt whatever it is the code is now doing. We try to bring a more arcane example therein to life. So just to give you some data points, and this is only collected via surveys of our own undergraduate students, when we ask them to what extent did they like our use of physical props in class to explain topics, it's pretty overwhelming that they at least liked it or loved it even, using these very coarse measures. So they were at least well received, as opposed to students rolling their eyes at these kinds of theatrics. We asked them more specifically, and this slide I'll defer mostly to the online version rather than walk through it here. This was like the dozen or so examples we did that particular year, and we asked students to categorize them more educationally as having been very helpful or not very helpful, or somewhere in between. So not just liked or loved or disliked or hated, but how helpful did you find? And they're ranked here according to those who found them very helpful. So tearing a phone book to explain binary search, wonderfully, is sort of atop the list. Refrigerator and milk to explain race conditions, so to speak, is second on the list. Plastic numbers to explain sorting. Mailboxes to explain pointers. Glasses of water to explain variables. ... Black box to explain functions did not play very well. And it might just be of how I enacted it. We didn't show you a picture, but I literally had a black box on stage so as to enact something like Julia Child, where I put something into the black box here, and then I pull out something here as the output. The idea being it's like, there's this black box abstraction that's turning the input into the output. I think I probably just didn't do it very well, or we've hypothesized that, OK, it's a black box. I get it. Like, there's maybe not cognitively that much of a barrier with maybe simpler topics like that. So just to give you a sense of how things were received, you know, we had several hundred students evaluating these particular examples. And here now, anecdotally, as we wrap up this session, would just be some anecdotal points from students on those same questions. It really helped me understand at a different level and helped me remember the material better. They made me comprehend something instead of just recalling it. For instance, I will never forget about locking transactions. Think double milk jugs. Or linked lists. Think boxes connected by arrows or pointers, not pictured here today. It helped me to visualize all of the code and ideas that would otherwise just be letters, numbers, symbols, and indents. It really helped me stay engaged, especially in the virtual nature of this semester. Were often unnecessary, helpful but unnecessary. For me, an animated diagram on the slides would have been sufficient, and I often felt that these demonstrations took up more time than necessary. I liked them because they were engaging, but I don't think they helped a lot with my learning. So here you see sort of different perceptions, and we ourselves try to struggle with sort of striking that balance, especially with large demographics of students. But I dare say we don't make everyone happy, or we don't necessarily solve a problem for every student. I don't really get value from stuff like that, but I know it helps others. And maybe that's the more important detail, is that if we at least strike the right balance, it's still a net positive on the whole for the class. But one other quote that was from a reviewer online when we were presenting this result at a conference was this, and I thought was very insightful and helpful for our own paper. In a teaching environment, there is a balance that needs to be struck between the inquisitive newcomer who we want to inspire and the more advanced early student we want to challenge. How much theater in the classroom for an individual class is advisable? And so that's, dare say, the open question, perhaps in today's meals or breaks. Feel free to consider the self, share things you've tried and succeeded at, failed at, or the like. But I thought this is something that actually guides our own thinking, trying to figure out just how much time should we really spend on the phone book or the light bulbs or the like, because there's also a lot curricularly that we want to present to students. So that then is CS50 explained. And let me pause one final time for any questions. And we can do that thing where we break the ice by have someone else volunteer someone else. Any questions at all? Or suggestions at all? Yeah, Peter.
I'm curious about the AI tool you were talking about. Does that rely on ChatGPT underneath it? Or is it coded entirely yourself?
A good question. The CS50.ai tool I alluded to, is it built on top of ChatGPT or made by ourselves? Mostly built on ChatGPT, or technically the API that's available from OpenAI that serves tools like ChatGPT. So you'll hear more about that later today and tomorrow, but we have been implementing different versions of this. One, the website that I mentioned, CS50.ai. Two, those of you who have used VS Code for CS50 might know that there's been for many months a duck icon that if you click, it lets you implement rubber duck debugging by talking to the duck. But for the past year and a half, the duck has only quacked at you either 1, 2, or 3 times. So that was the extent of our AI. It was pseudo-random, 1, 2, or 3 quacks. But as of like a week ago, the darn duck started talking in English. And that's all thanks to Rongshin and Andrew and Charlie and Patrick and the team. So you'll hear more about that too. And you'll also see that we'll probably soon roll out support for terminal windows. So when students get an arcane error message, they've had Help50, a tool that we've long used. And Help50, we hope, is about to get a lot more helpful and more generalized. And you'll see some other things in the works as well. Other questions? Yeah?
I know you're using teaching, or like the undergrad teaching assistants. Do you do a training for them at the start? And would those materials be available if we're trying to train our own potential teaching assistants?
Absolutely. If you're looking to train your own teaching assistants is the question. Do we make materials available for our own TAs and the like? Yes. So at the beginning of our fall semester for the large class here at Harvard and Yale, we have TA training, fall training, so to speak, where we do introduce them to some of these same topics, though not in as much detail, to give them a sense of not only what they will be doing, but also why and how. And so we're happy to share those as well. And maybe just catch me or Carter during a break. And we'll talk more about this in the coming days, too. But of course. Yeah?
For the theatrics part of the discussion that you were talking about, if we find something that's helpful throughout the course and we want to share that with others, is there a place for the CS50 educators, whether it's like the Discord or something like that?
Indeed. We've been using email in recent years just to make it accessible to everyone. And you'll all be invited, if you haven't been already, to the Educator email list, where we would love for folks to talk all the more about stuff like that. And for those on video, question was about sharing one's own ideas and theatrics with other teachers. Indeed, we'll do that via email. Other questions? Yeah?
Yeah, I wanted to talk about the programming language. All the examples seem to be about C, and I can see that there's some maybe low-level things that brings up. But if you were forced not to use C, what language would you
A good question. If we were not using C, what other language would we use? Probably Python nowadays, I would say. And there's certainly a lot of momentum building for that. I personally think it's a better choice for a first programming language than Java, only because there's a lot of stuff in Java that gets in the way. Public, class, void, main, and like the need to have class. Then this is changing, I think, in a newer version of Java, so this will be less of a concern, but it's taken them decades. Python is probably the nice balance nowadays because it has pretty accessible syntax. It's pretty readable. It has a really good ecosystem with libraries. You can do things graphically, command line, and the like. Personally, we still use C for about half of CS50 or about a third of CS50 because I philosophically actually like starting from that lower level and building our way up and then abstracting away what we did the first 5-6 weeks of the class. I think a more typical approach, admittedly, is for classes to start only with Java, only start with Python, and then a subset of students might take a systems level class and go that level deeper. Personally, and I am in the minority on this nowadays, I do think, personally, I think I prefer the other approach because so many students will otherwise never really know what it is that's being abstracted away from them. With that said, per my first comment today, assembly language is a little too low level, I think. So there's something about C that's kind of in the sweet spot for me. Not without challenges, pointers and syntax and the like, but there's some juicy info there, some juicy topics. Other questions? Yeah.
Do you think at some point in the near future that you'll say the same thing about C that you just said about assembly?
It's a good question. For those on video, do I think I will say about C what I just said about assembly in the future? Probably not, because, well, at least in the next 10 to 20, well, I don't know. You know, the thing that's, if you had asked me a year ago, I probably would have said, no, I think I'd stick with that. But AI, I do think, is going to make programming much more accessible in terms of natural language and just tell the darn computer what it is you want to do. And it'd be pretty stupid if we're still constraining ourselves in 5, 10 years to very arcane syntax, limited grammars, when the computer can just figure it out. So maybe will now be my answer, that we'll look back on this as very primitive times where you had to use these very arcane languages and limited grammars to tell the computer what you could just tell it in English or some other common human language. We shall see. Play back this video in 10 to 20 years, see what happens. How about one final question before we'll take a 5-minute break and give Carter a chance to set up? Final questions from Charlie online.
Yeah, sure thing. So a question from Helder, going back to theatrics for a moment, they're asking, how do you determine the right amount of theater in the classroom?
It's a really good question. How do we determine the right amount of theater in the classroom? For me, it's honestly been trial and error. I do think on occasion I've erred by spending too much time. I try to keep in mind data that we have nowadays. Like, I know what has played well, for better or for worse. And so, like, we still do the phone book example. We still do the sorted numbers example. I don't necessarily do some other demos anymore that aren't on those lists. So I think it's two answers for me. One is instinct, like literally read the room and see if, like, we're drifting off topic too much for too long. And two, ask students and then get it right the next year or get it better the next year. All right, well, why don't we go ahead and take a 5-minute break here, and when we resume, Carter will dive more into the curriculum.